All right, so the cosecant graph um, returns to using sine and cosine rules. So we no longer use the tangent, cotangent stuff. And what I like to do is just remind myself that cosecant will be going with the sine curve. So the amplitude is 3. Remember, amplitude is always positive. That negative will have to be incorporated by flipping our graph when we're ready. The midline will be going down 4. The b value is the 2 sitting right in front of x. And then the p would be, again, we return to the 2 pi rule, so 2 pi divided by b. So 2 pi divided by 2 is pi. And then the critical points, again, are the period divided by 4. So remember, we use the sine, cosine rules for these. So the period is pi, and we go pi over 4, so that's how far we space them. Now the phase shift is the 2x minus pi over 2. Set it equal to 0. Take 2x, add the pi over 2 to the other side, divide by 2, and I get an x that's equal to pi over 4. So I will move over pi over 4 for my first critical value, and then we're going to add pi over 4. So pi over 4 plus pi over 4 is pi over 2. Add another one is 3 pi over 4. Add another one, we're at 1, or 1 pi, and add another one, we'll be at 5 pi over 4. All right, so now we're ready to graph the function. But before we do this, we have to understand that cosecants are the reciprocals of sine. So what I'm going to do first is just do a sine curve as a ghost line. So sine wants to start at the midline. So we have to move our midline down 4. 1, 2, 3, 4. And then the amplitude is 3. So if I go up 3, I'm at -1. And if I go down an additional 3, I would be at -7. So this will be the maximum, and this will be the minimum. And so with my sine curve, I'll start at the midline, and I will go up to the maximum first, except there's this flip in the graph. So instead of going up to the maximum, we will go down first. So I'll be down here at a minimum, and then back to the midline, then to the maximum, and then to the midline. And I'm going to do this as a dotted line. This doesn't really show up on our graph. And so now I will, I guess I could draw in this midline. So the idea is whenever the secant or cosecant hits the midline, that's where you're going to have what are called vertical asymptotes. And so right here, we're hitting the midline. So I'm going to put a vertical asymptote across or down, and I do another one there, and then I do another one there. And so the idea is the actual cosecant graph will show up touching the minimum, and then we'll draw a U-shaped graph that goes down in between the vertical asymptotes. And since there's a maximum, we'll go up touching that vertical asymptote, or touching that maximum of the graph and going up between the vertical asymptotes. So if I go here and I go to y equals, and I clear some of this stuff out, we had -3, and then I had to do 1 parentheses 1 divided by sine, and we had -3 cosecant 2x minus pi over 2, 2x minus pi divided by 2, and then a -4. Now to get this to look, I need an extra parentheses there. So if I graph it, you're going to just see all these U-shaped graphs showing up. So what we'd want to do is take our window, and remember we shifted to the right pi over 4. So I'm going to say to the right pi over 4 by just putting positive pi over 4. And then we want all the way out to 5 pi over 4. So I'm going to type in 5 pi over 4. And our x scale we counted by pi over 4. And so then you can see our graph, what was happening. And if I put the midline in here, maybe that would help us a little bit. The midline was at -4. And so you can kind of see where we're at and why the graph turned out like that.